Firstly, I'd like to point out that this colour is coral, not pink. We've got to see the Friends episode with the salmon shirt. Think about our colour. So, yeah, we recently renamed to Bean. If you'd like to know why, I can explain later. We'll talk about our journey from sort of large grain services to small grain services. Firstly, Bean is a social network. We've been in sort of self-denial for a couple of years that that's what we actually are, but finally admitted that yes, we are a social network. And we're a second screen application. So the idea is you sit watching television with your iPad or your iPhone or Android, and you interact with other people, maybe during the advert, maybe during the show, depends on. You can find out more information about the programs, you can see what's on, you can chat in what we call TV rooms, you can engage with other users. So that's the idea, is to try and bring people together around television and the things that they love. So that's been good. So when we started, we had, I guess, a very short amount of time to put something into production. We felt that there was a very small window for this second screen idea to actually make it into the marketplace. So as with any startup, which is really a mechanism for turning ideas into technical debt, we went about that. And we produced several sort of large grain services. They were written in Scala because we were cool. We didn't do Java. To be honest, we did have one Java application. They were essentially large grain applications that sort of fit together in a sort of traditional way. So you have the typical layered approach. And they were big and they were unwieldy, and we pushed this thing into production, and then we found some problems in it. It didn't scale very well. It was very hard to change. We had all sorts of bugs, all sorts of technical debt. It was a real challenge to sort of move things forward. And we sort of sat down and thought about ways to improve things. Of course, we thought, okay, we've got to carve this up. We've got to attack this problem in pieces. We can't do it together. So we decided to start moving towards smaller grain services. So rather than big monolithic apps, smaller grain services. The problem is they can look a bit messy. So you can have lots and lots of pieces. The volume here is actually smaller than before, but it's a bit of a mess. But we went about breaking our monolithic apps up into much, much smaller grain services and sort of pieced them together in a way that made sense to us. Anybody looking from outside would probably wonder why things were that way, but they had a reason. But one of the good things about having small grain services is the way that you compose them. You can put them together in ways that you didn't expect to in the beginning. And when you're in a startup and you're continually changing to meet what you think is the consumer's demand, having the ability to change what a service gets used for is really, really valuable. And it makes a really big difference to your team's morale when they see that the work that they've done has not been wasted and has to be rewritten, but can actually be reused just by another service. But it has challenges. So, do we use microservices? No, not really. Not by the way that it's often defined. Although I think the common definition, if you've read Mark Fowler's recent series of blog posts and the associated blog posts, I tend to think of them as more nano services where you're pretty much taking one function call and turning it into a service. Will we ever get to that sort of granularity? Perhaps. If we see there's value in doing that, then we will do it. We'll only go where there's value. So we turn to sort of fine grain services. So they're more milli services than that. So they're more arranged around sort of single units of functionality rather than discrete pieces within that functionality. And we can argue about what defines functionality. So reducing the granularity has some real advantages. Your separation of concerns becomes a lot more explicit. Your persistence tier is only dealing with persistence. Your user tier is only dealing with users. Your activity process is only dealing with activity. You don't have to worry about concerns bleeding into each other. Those services themselves become much easier to understand. There's a lot less accidental complexity around the code that you're writing. So it's much easier to understand what's actually happening within the service. So you can take it from the API down much easier. You can evolve these things much quicker because your service is much smaller. There's a lot less of this mental, well, I've invested all of this time in this massive monolithic application, I don't want to throw it away. If you do things right, you get availability and scale from these sorts of things. You can get it with monolithic apps as well, yes or no. But I think it's a little bit easier with kind-of-run services. And it enables you to think more in the right paradigm for the service that you're building. You don't have to try and build everything in the same paradigm. So if you have a batch service, it is a batch service. If you have a reactive service, it is a reactive service. You don't have to deal with trying to blend different styles of application within the same language. It has its disadvantages though. So you have a lot more services. There's a lot more things that can go wrong. You have a lot more things in production. If you make a mistake that affects all of your microservices, you're in trouble. You've got a lot more things to deploy. Deployment is often, that last mile is often the hardest bit of the job. Getting that stuff into production is often the hard job. And once you've got them there, how do you find them? How do you work out what's wrong? You've got logs everywhere. You can't sit and SSH into 1,000 machines. It's just not going to work, no matter how good you are with batch. And you can also get some really funky dependency change between the services. So you can end up with services depending on services that you didn't even realize they depended on. And it requires a lot more thought when it comes to the plumbing and the infrastructure around these services. So in our experience in reducing the grain, it's improved our maneuverability. So what do I mean by that? So it's improved our ability to change what we're doing without losing any momentum. So we can reorganize services if we need to. We can make use of existing services much easier. We can get new ideas into production much quicker. So it's reduced the time that it takes to get a particular feature out. If there is a particular feature that we need in production, we can just write a service to deal with that feature. Often overlooked, it improves morale. The way that we work, teams feel like they have much more influence over what they write about. They're not being told from on high that you will write a Java Tomcat application that does all of these things, and you will be responsible for basically turning XML into snapshots. We also take an architectural approach where teams are responsible for the architecture of their slice of the application. So that gives them a much better feeling of control over what they're doing. And gets them much more motivated, gets them thinking about it. But this does require discipline. As you're seeing, there's API versioning is a consideration. You do move that problem from integration to interoperability. You do have those concerns. You have to be much more careful about retiring APIs. You need to put a lot more thought into it. So how do you make these sorts of things possible? So I think one of the big things that's often been overlooked is this idea of some agreed conventions. So one of them that we have is called Essential, which is Software Engineering Spec number 4. It got written when we started, which basically said every service will offer these endpoints. So every service has a service endpoint, and under that it has things like status, health check, and a health check good to go. Really simple things. But a really simple thing like that makes it much easier to work out what's going on in your platform. You can tell whether a service is up or not. You don't even need to know what the service does, or even who it is. You can see if it's up. You can see what health checks are coming in. So again, you don't necessarily need to know what the service does. You can hit the health check and say, it's failing to connect to Sunday. Okay, so we know there's a problem. And the service status. So we can see what the version of the service is, and some information about when it was built and how long it's been up and used. And that's a really simple idea, but I think it has saved us probably hundreds and hundreds of man hours over the last couple of years, just by knowing that I can curl this URI and know that I'll get this information. Automation. Yeah. you have to be automated. You can't deal with fine-grained services if you're not automated. Like I said, you don't name your servers. We don't even know what half our servers are, and they're going to change within the next couple of hours anyway. And also tooling. And by tooling, I mean the tools that you need to build for yourself to make your life easier and other people in your organization. There's some really simple tools that you can build that really help move things along. Some of the must-haves from my perspective are, you build it, you run it. You can't go into this with a traditional operations team. A traditional operations team is not going to be able to handle, I think we have 87 services in production at the moment. You're either going to have a massive operations team and be bankrupt, or they're just going to go insane. So your product teams need to own the services in production. Also, from my point of view, as sort of chief architect and a director of engineering, it has to be, you have to trust that these guys are actually going to build things the right way. If you don't trust them to do that, you're going to go insane. Or you're going to spend hours and hours trawling through code, making sure they're doing it right. So there is a high trust involved in this. And the other thing is you have to look for very gradual improvement. So if you're going to move from monolithic architectures towards sort of fine-grained services, it's not going to happen overnight. So as an example, when we moved, there's a few people in the room who understand the connector, which was one of our original monoliths. If you want to move that to fine-grained services, the way that we did that was we actually stuck another service in front of it. And for the first couple of weeks, all it did was proxy calls through to the original service. We had to add some new functionality, which was going to be a real pain to add connector, but that was fine. We already had this layer where we could hide that functionality off to somewhere else. And it also meant that we could start carving up connector underneath, and we could protect our users from the changes. We actually moved from simple DB to Cassandra with no downtime, no interruptions, no user awareness that this was going on. It worked really, really well. Having good deployment pipelines, so being able to get your stuff into production really, really smoothly. This is a must-have. Our platform team was very proud that we can get stuff into production in an hour. Of course, I beat on them and say I want it in 20 minutes. But having a very reliable way of getting your code, a one-line change, into production is extremely valuable. You need logging aggregation and those sorts of things. You need to bring everything together to a central place. Like I said, you're not going to be able to SSH into 1,000 servers to look for a particular log line. So you need ways to make this easy for them. And also one area that I think that's left out quite a lot is you need some way of knowing that your features are working. So this is different to your services. You need to know that the features that your customers are using actually work. And you need to be sure that they work all the time. So I think continuous testing of your platform in production is really needed. And you also need to understand that it's important to invest the time in that tooling, in making things easier, so that everybody within your organization can self-serve. So, this is Zeebox. So at Bingley we have product teams who are responsible for vertical slices of the product. We also have a platform team who are responsible for sort of core services. So if you think of things that are needed by 2 or more teams, they tend to gravitate towards the platform team. Things like the AWS infrastructure itself is the platform team. Things like Cassandra, the platform team. But a lot of their work is really in assisting the other teams in making their job easier. So we want to make it as easy as possible for a product team to get their new features into production as quickly as possible. So a lot of that team does is making sure the tooling works, making sure everything is nice and smooth. So we use ThoughtWorks Go, loved and hated by various people in this room. It works very well for us. So it's not a continuous integration tool. If you try and use it as a continuous integration tool, you will hate it. It's a continuous deployment tool. So you can see that we've got a slice here of one of our services, and we can build, we can release, we deploy into our development environment automatically, so nothing gets touched for this particular service until after deployed into development. So if you're happy with the service in development, one click, it bakes an AMI that then verifies that those AMIs work, deploys it into the staging environment, and then actually tests that the same AMIs will work when they go into the live environment, and then it waits. So then it's in the staging environment, so you can verify that in a live-like environment, everything's working fine. And then we have one click to deploy, start deploying into live environments. We actually have 3 live environments, don't get me started. But,
sorry, what application is this?
ThoughtWorks Scope. It is the worst name to Google. Why they chose that name is beyond me. It's sort of an evolution from cruise control. It was called Cruise for a while.
That's right, yeah.
Then they changed the name to Go. It's just been open sourced, although the source code is not available yet. It'll be available in summer. So it's a great tool. So it's saved us a lot of heartache. So we have, I think at the last count, about 112 pipelines like this. Some for services, some for other tooling. We actually have one service that recently has become automatic all the way through. So it has 100% coverage on everything. It's a very simple service. It's not one that's likely to change, so we're very confident in it. So if it passes all our tests, there's nothing that a human tester would find that these tests don't, and will go straight through production, which the guys are really chuffed about. I'm not sure if I should tell the CTO to do that. But we actually have manual steps in places because we have some big partners who are a bit nervous about deployment at particular times. But for most of our services, we can deploy into production and we don't miss a beat, people don't notice. So tooling. So one of the challenges of having fine-grained services is understanding the dependencies between services. So we put together a quick tool to try and visualize how the architecture came together, what services depended on what, and also gather information from the platform itself. So this is just a quick screenshot of one of the components. I've blanked out the names, not because our naming is horrendous, which it is, but because the names are not on brand anymore. So we need to sort that out or something. But it gives you an idea of, we can see sort of what the dependency is. So the item that we're looking at is the one in the middle, and we can see that it's depending on Cassandra, so this is the persistence tier. And we can see all the things that depend on it. At the moment, this is just in a graph database. We just build this very quickly. But we actually have all of the endpoints in the system because of the health checks and so forth. We can actually work out what the dependencies are. So I'm having very soon that this will just come out of the system itself naturally. So if somebody adds a new dependency to a service, this should just compare. And also has a link. You can't see it on the screen, but there's a link down here to what clusters this service is running. We're using Netflix Asgard at the moment. So we talk to Asgard and find out what services are, what AMI is running on that platform, what the size instance it is, how many they are, and what balance is like. So it's really, this was written in, it was probably 4 or 5 hours, but it provides a lot of value to people. So we really got a lot of value from in the future. And we provide links through to the GitHub repository, the runbooks and other information from that. So, any questions?
John?
Thank you. One of the objections or criticisms of microservices is that it forces you to declare the isolation between your different services too early in the development process. How much of the learning about what those barriers and those interfaces are did feeling go through based on the early pictures you showed, the big Duplo boxes? And how much was it because you were inheriting perhaps a former code base that may have some of those things already declared within it?
Yeah, so I think the challenge there is understanding your domain. So whilst we have these big open monolithic applications, which I must admit I'm responsible for, by doing that we learned a lot about the domain, and we learned how to carve it up. So we learned about the APIs that we need. The big thing we find now is that because the services are so fine-grained, it's very easy to move in a different API if you need to. It's very easy to retire a service. I'm always happy when we retire services. I think I'm more happy when we retire than when we move to production. And whilst it's, in some ways it's difficult to do that, in other ways it's quite easy. If you see no activity in the access log for service for 2 weeks, you know nobody's using it. In our case, we know nobody's using it. So it is easy to evolve the services. There's a tension between whether you build clients for your services and what other people build them, or whether those services should build their own clients. For our services, we've been producing clients in most cases. So people just build them in as libraries. They're not talking at the HTTP level. But in a few cases where we've not wanted to add the dependencies, or we're in a completely different language, we'll just talk at the HTTP level. But yes, it does, in some ways, force you to think more earlier in the process. I don't necessarily think that's necessarily a bad thing to do. I think most of the challenge is understanding the domain you're working in, rather than how to write code. We all know how to write code. Anybody can write code. It may not be good, but they can write it and it can work. But yeah, it's a trade-off. You're making a conscious choice, to sacrifice some things in order to gain other benefits.
Okay, I think the piece hasn't arrived yet, so we've got time for maybe a couple more questions. Okay, over there.
You mentioned some common endpoints that you have for all your services. Are there any frameworks, or is it all custom built in-house? Because I remember you saying that you use Scala, and Scala drop wizard, we use quite a lot of drop wizard with Java, but the Scala drop wizard stuff's pretty cool. It has all the health checks baked in for it.
So yes, we use Scala. We also use Node. We also have a bit of Python around and some Clojure. When we started using Scala, which was 3 years ago, so there weren't many Scala frameworks of any sort of maturity. When we originally started, we were sitting on top of Tomcat, and we were just implementing servlets on Tomcat. We moved away from Tomcat to an in-house HTTP server written on top of Netty. Mainly because we didn't like how long Tomcat started. We wanted sub-second startup times. Tomcat just couldn't do that. So yeah, most of our stuff is built in-house. We have a few services that are built on top of Play and implement sort of Play endpoints. But we don't use any particular framework to give us that sort of goal. It's just something that every service needs to build.
Any more? Okay, thank you very much.